starting.
Great, thank you. So Leah McEwen is a chemistry librarian at Cornell University in Ithaca, and she and I have been working together since I was in Ithaca in 2013 or 14, I think. And this is sort of we've been sharing our work as we go with both the Division of Chemical Health and Safety and the Division of Chemical Information. And this is sort of an update on sort of our next steps in moving forward. So I just want people to have a reasonably good sense of that this is a long-standing project that we've been working on, trying to understand how best to organize, collect, organize, use chemical safety information, particularly in a research laboratory setting, but both also as an educational tool. So what we're going to do is first we're going to show you a video that is not quite ready for a public release. We've been working on it maybe 6 months now, since we originally had the idea for using a video, a short form video, 2.5 minutes long, to talk to chemists about how to collect, organize data, both to support safer experiments, but also when they publish to provide safer information for the literature. So I'll show the video now.
You can think about a research experiment in the lab like creating a new cake recipe. In the kitchen, just like in your lab, you have to figure out which ingredients you need, how much of each, and the best processes to use to get the job done safely and with a great outcome. Sure, there are lots of rules that apply to what you're doing, but you can't turn to a recipe book for all your steps. After all, you're doing something new. Yes, in your lab, your chemistry knowledge, experience, and critical thinking will help you, but you also need well-organized information about hazards and tools to assess risks from these hazards. Having excellent data and a clear risk assessment will not only make your experiment safer, it will make it much easier to publish and replicate your work in the future. It's just good science. FAIR and RAMP are two acronyms that can help organize this part of your work. FAIR data principles help you figure out if you have high quality data that are findable for you and for others, accessible, available to everyone, interoperable, not specific to one product and can be interpreted for your needs, and reusable, so others know where it comes from and that it's real science, not fake news. It's not enough to look in the usual online sources. Try a public safety data source like safety data sheets or laboratory chemical safety summaries from the National Library of Medicine to gather and organize the data you need. Then it's time to mix your batter by combining the data you found into a risk assessment that describes your safety precautions built around the RAMP template. RAMP guides you to recognize hazards, assess risks, minimize the risks of hazards, and prepare for emergencies. Do a full risk analysis using your chemical properties and data and thinking critically about how that data interacts with your specific process and variables. It's done, which means you'll take your RAMP assessment and review it to improve your experimental planning, safety controls, and thinking through emergency procedures. And here's one last very important step. Share your recipe with your colleagues, including your risk assessment and lessons learned. After all, safety data isn't intellectual property. Making safety data transparent and accessible is important for all chemists. More and more, publishers and peers expect you to document your risk assessment process in a way that others can appreciate and use. And believe me, your future self will thank you for clearly recording your data instead of thinking you'll remember. So make notes and share your own data. Fairly contribute to lessons learned and help build our community database of safety information.
So as I said, Leah and I have been talking for years about the best way to support the safety information needs of both the chemist and the EHS professionals to support the chemists. And I think it's something that until 2010 or so, we didn't really start thinking about information science as part of the EHS process. And so I felt very lucky when I met Leah at Cornell, and we've been able to build this partnership between the divisions over the years. And I think we've been able to improve both the practical needs, provide practical tools around this issue, but also come up with new ideas that we can move forward. One of the ideas when we were talking about today's session, one of the ideas that came up is a story that I had left over from when I was at the University of Vermont. Our animal science department there called me up one day as the hazmat guy and said, we just found this 5-gallon can in the back of the stock room. And we think it's DMSO, but when we open it up, there's nothing but solids in there. And as a hazmat chemist, I started thinking about peroxides and explosives and all sorts of other scenarios. And fortunately, I had the EHS common sense to look at a safety data sheet, and I realized that the boiling point or the melting point was very close to room temperature. So we realized that probably the simplest explanation for the DMSO being solid was that it's frozen. And we did enough of an assessment to convince ourselves of that, and it worked out. But as I mentioned that story to Leah, she had, well, the reason I brought it up is that she mentioned that she had been finding a lot of interesting content about DMSO as she was looking at various forms of safety literature. And so, Leah, do you want to start telling that story?
Sure, Ralph. Let me see if I can share my screen. Can everybody see? I'm not sure. Maybe Ralph. Okay, let me try again, just because I think you were still sharing there.
There we go.
Is that working for people? Okay. Yeah, great. And I can't see like things like chat. Maybe I'll just quickly bring up the chat window, okay, in case anybody has. One of the things I wanted to say before I got going on this was if you, I mean, first of all, there's a lot of people on this call who have great expertise in chemical safety information, from which I've learned a lot. So keep this conversation going. And if you're thinking of additional sources, you know, that we could compile and share, please put them in the chat. Please and tell us why you found them useful, because we're compiling all kinds of lists for different needs and use cases as we go. So as Ralph mentioned, you know, we were looking at DMSO. It's a very common solvent in chemistry research, so it's been coming up a lot lately. As Ralph mentioned, so this is an SDS for it. You know, go the place to start, right? So as Ralph mentioned, if you look at the melting point, sure enough, it's very close to ambient. So if it was in a cool cupboard, you might expect that it would solidify a bit. You know, and if you look at you know, the GHS information it seems pretty low, category 4 flammable liquid, a warning for the signal word. You know, if you look into toxicology, the limits are quite high. I know Ralph was doing some Google searching, and you know, some people are suggesting you could practically eat it, but not that you'd want to do that. But you know, so it doesn't seem to be in and of itself, you know, fairly benign relative to a lot of things that get handled in a laboratory. But when you think of the fact that it's such a very common solvent, any potential risk there might be would be, of course, probably a higher likelihood for exposure. So when you look a little more carefully here, you can start seeing things like in this section that, you know, it's readily absorbed through the skin. And if we think about it being a solvent, what's been dissolved in it in the course of a laboratory experiment? And if this landed on your skin during an experiment and it had something a bit more toxic dissolved in it, you know, that's in you now. So there's a little more to it, I think, thinking about chemicals than handling one by one. And that's been one of the challenges that we've all been trying to work on in this group is thinking about chemicals in context and together. And, you know, of course, chemists are all about studying reactivity. You know, they are trying to get chemicals to react together. So trying to understand how to think about that context more. Going back down to the section 10 here on stability and reactivity in the SDS, you can start seeing more about incompatible materials, hazardous decomposition products. A lot of these materials that are under incompatible are things that chemists are using in their reaction mix. So, you know, it's maybe a little bit more subtle with DMSO than the SDS might initially suggest. So I was just going to walk through a few sources, you know, and I think probably most of you would be familiar with these, but just to give a feel for the type of information that's out there. And again, this is pretty casual. So this is a resource that Ralph and I, through our collaboration, we reached out to PubChem, who they work with in the National Library of Medicine alongside PubMed, the literature resource. And from the PubChem database, they compile data about chemicals from hundreds of sources. And we started working with them to build a view for chemical safety, pulling just a few of the most authoritative sources together to create a separate dynamic view. And so for those of you who haven't seen the LCSS, when we say that, this is what we're talking about here. Here are some of the information sources that we're pulling from. So many of these are probably familiar to you, and this brings data from some of those sources into one view. You know, it's mostly it's intended as a starting point, sort of starting your search. So for example, for DMSO, if we look under, say, health and symptoms, pulling a lot of data from ILO here, you can start seeing a few more hazards called out there. Again, the decomposition, the exposure route, a little bit of the issue about the fire hazard. If you go down here under stability and reactivity, again, that decomposition, this is where it's starting to maybe get a little unnerving, right? Decomposes violently. And then you see from the chemical safety library, and the chemical safety library is now serviced through chemical abstracts. Then in fact, a couple of incidents have been reported where it's been explosive mixed with certain other things, including, say, hydrogen peroxide if it's heated high enough. So that there's potential concerns here when you're working with DMSO. It's worth looking a little farther maybe. So for example, if I go back up under here, this was an alert from Cameo. I'm just going to open this up. This is information that PubChem pulled from Cameo that describes a little bit more about the context of what's going on in Cameo here. So that's kind of helpful. You can open right to the record in another screen. So for example, here's my DMSO in Cameo, yet another source that compiles data from a lot of other places. But one thing that Cameo does is they group compounds. So for example, they group like compounds together, families of compounds that have similar reactivity, similar reactive groups or functional groups within the chemical structure. So they may have some similar reactivity. And then they, through reported incidents, they classified and organized these incompatible groups. And that's where a lot of these incompatibilities are coming from. So for example, I searched it against sodium hydride, which is a very strong base that's often used in chemistry. And you will see these mixed together used in some chemical research. What happens when I ask Cameo to predict the reactivity between these two compounds? And then this is where you're seeing, Cameo doesn't think it's so compatible. This is where your reaction products from mixing these may be corrosive, may be flammable. It may liberate noxious gases. It will likely generate an exothermic reaction, even at ambient temperature. And so if there are other factors in your setup that might kick that reaction into higher gear, if you're not controlling the temperature, if you don't have a chiller on it, you may end up with a runaway reaction scenario. So again, there's more to this going on than just DMSO all by itself. So then I thought, let's take a look at Breathrix. So for those who don't know Breathrix, it's been compiled for decades reported incidents from the literature. For example, here's a few references here under the DMSO entry. Actually, the DMSO entry is quite long, which means there's been quite a lot reported. Some of these are industrial scale, some of them are research lab scale, some of them are testing that was done. So there's a lot of information in Breathrix also about reactivity. It is the Breathrix Handbook of Chemical Reactivity Hazards. And it's organized around the compound. You need to look it up in the index, and here's the compound number for DMSO. And you can see here acids and bases. There's been some reported incidents here, and many others. So again, because DMSO is so common, commonly used in the research lab, I think it's something for us to be familiar with some of these things that are going on. So then I went over and I thought, well, I'm going to look in the journal that ACS publishes called Organic Process Research and Development. And this journal is pitched to be a communication tool between industrial chemists and chemists working at research institutions, including universities, because ultimately, the industry would like to make use of some of the research that's generated in the academic sector, but those processes that are worked out in the university need to be scalable. So this is a really great journal for compiling a lot of the studies on how you might refine and optimize and scale up those processes. And there's quite a lot of studies in here that are targeted at evaluating potential hazards in doing that. And so if you I just did a quick search here on hazard in this journal and came up with over 1,000 articles, for example. So this is a resource that we could be looking to, I think, a little bit more. I know some of us are quite familiar with this journal, but I'm not sure how often all of us think about it, especially if you're presented in one of your research labs, with where they need to have a little more detail about the kind of chemistry they're doing. This may be a place to look. So for example, one of the articles that came up is, look at this, explosion hazards of sodium hydride in DMSO, which is what I was just looking at. This article was done in 2019. This is quite interesting to me here. This figure over here, the red part of these bars is the number of articles that have appeared in organic letters using that sodium hydride in DMSO. Here's Journal of Organic Chemistry. Those are two of the top journals where organic chemists and research institutions are publishing. So it is pretty frequent, use there that this is happening. And the other solvents that they mention here, DMF, is actually quite hazardous in its own right, and that's even more common. So I think we need to be aware of the kind of things that chemists are using. And they did a number of studies here. Here, let me see if I can get a higher quality picture there. This figure right here, it's a little hard to see. I could probably, I'll just quickly look at it. You could probably at least see the curve on here. This is temperature on the bottom and the heat rate on the top. So basically you got to about 50 degrees centigrade, and all of a sudden you had a runaway reaction happen, a huge exotherm. And in fact, it actually ruptured the chamber where they were studying the reaction. So you can see the picture over to here. So this is interesting to me because the boiling temperature and the decomposition temperature for DMSO is actually almost up to 200, 190 Celsius or so. So this is actually quite a bit lower, much more in the range of many common reactions in lab are run at more at this temperature range. So when you start blending reaction mixes together, I think it's something to think about, that some of these hazards could really be amplified. And I know many of us think about that when you start thinking about chemicals in the context of an experiment mixed with other things under certain conditions in the experiment. So even at small quantities, I think we need to be mindful of the potential. Here's another article that came up. This is just this past summer. This is actually studying the autocatalytic decomposition of DMSO. And in fact, their point here is that as it's decomposing, it's generating acids, and that those acids will accelerate the decomposition. So once it gets going, that decomposition will go that fast, as we saw in the previous article. So this is a known thing, and there's been some really good studies on it. One more article that I came across here. This is also a very common kind of chemistry, are these palladium catalyzed reactions, often conducted in solvents such as DMSO or DMF. And they are often done in one pot. All of the materials are put into the reaction vessel all at once at the beginning, and then they start with the heat and everything. So again, there's another situation where you've put it all together and you've started it, and once it goes, it's much harder to control when everything's in it. You know, you're not adding things drop-wise or anything like that. And there's some, you know, they went through the study quite thoroughly here and looked at you know, here's different combinations of solvents and dilution of solvents and things to kind of study this heat rate curve, how fast the heat went up. So there's been quite some good research on things like this. So I think I just wanted to call this out, this journal, that we might want to think about using it more. And then I wanted to mention also, many of you have heard that Sammy was on this call, and I published this chapter recently. And the reason we did that is because the ACS journals and many journals from other publishers as well have started incorporating more requirements for researchers, you know, to describe significant hazards or risks associated with the research work that they're reporting. And this is a relatively, the momentum behind this in the more regular research community beyond the industrial oriented research is relatively new. And we haven't found a lot of this reporting previously in sort of the mainstream chemistry literature, say, such as Organic Letters or JOC that I mentioned. And so this effort is to try to work with researchers to think a little bit more about these hazards and report on them and how they're managing them. So this is why we wrote this chapter here, for example. And we have this section called Recognizing Hazards, where we kind of walk through some of this. You know, so in addition to the GHS, for example, there's a number of things that can trigger, you know, escalate what may have been a lower risk into a higher one, including, for example, things like this, the high exothermicity, like you'd expect in some of these reactions we were looking at that are done in DMSO, for example. And then I just wanted to say, back to this author requirements for ACS journals. Well, the chapter in the guide, there's actually a whole guide with lots of great topics in it. This is a really excellent resource. If you just need to look at the chapter, there is a PDF version linked right from the ACS guidelines. So I think that's available for the community, and we provide a link to it in the library that Ralph's going to show. Do you want me to show that library, Ralph, or do you want to show it?
You can go ahead and show it. Okay.
So one of the things, as Ralph mentioned, we've been starting to compile information sources together for a list on DCHAS, basically. So we've started here. We don't have a ton of resources in here yet, but we're just, you know, exploring what we could list here and how we want to present this to the community. We're doing this through a tool called Zotero, which is a reference manager. And right now we have sort of two folders. So general sources, and when we say general sources, these are actually the ones that Sammy and I compiled for that chapter that I mentioned here. You know, and it's just a kind of a broad diversity of sources to think about, you know, the hazards and assessing the risk and how you might minimize and prepare. So walking through the RAMP process, sources that address that whole range of activities. We've also tagged them by different topical items. So for example, if you clicked on PPE, here are resources that address PPE related information. There's a lot of nano safety ones in here because I was compiling the citation list from the nano safety resource that the Committee on Chemical Safety recently published. It's sort of my experimental set. If you click on this link at the top here that Ralph provided, it opens the library in this view, and it's a little easier. And from here, you can actually see, you can see a little bit more information. So here's the journal that ACS publishes on chemical health and safety. Many of us have published there. For some of these glove guides, we've included the PDF as an attachment if the PDF is openly available, things like that. So I think that's pretty much all I wanted to share.
So we have an active chat as usual, and
great. I haven't had a chance to look at it yet. So go ahead, Ralph.
So
you talk and I'll listen.
Neil got to the heart of the matter as he usually does and asked, the title of today's chat includes the word quality. In the context of the massive information you just pointed out, how will we address quality assessment? How do we assess the quality associated with all the different sources of information that Google or anybody else will provide to us? And since you're the librarian, I'll give you the first shot at that.
Okay. And there, that's a great question about. So, and I guess the first thing as a librarian, and there are other librarians on this call as well. But one of the things you want to start with is what you're trying to do. And I guess in here, if you're openly searching on the web, that's a different kind of question than if you're already starting with some of these resources, such as that we're featuring here. But even if you're using sources like these that are recommended, by different expert communities, even then you still need to look at the data as you're going through and understand if it's appropriate for your situation. So, for example, some of this information may not be relevant at different scales of work. As we were looking at with DMSO, it looked pretty innocuous on the SDS, but then when you mix it with other things. So when we think about quality, was the data well collected? Was it curated in any way as it was published? Those are two facets of quality, right? And once it does get published, it's still on the reader to understand what the context is and whether or not that's appropriate for the research that they're doing. And there's a lot to it. One more thing, Ralph, I wanted to mention, in the Committee on Chemical Safety, we've started a project in there about this issue, because in fact, there's a lot of different organizations that have worked on chemical safety data, and they're very disparate, and they don't always follow the same approaches to curation. And so there's gotten to be a lot of mismatch, and not all of them are updated very frequently. So there's quite a lot of issues around this. So we are working on that in the committee. That's a kind of a long-winded answer.
Neil, before you get a chance to chime in, I just wanted to say that that's one of the reasons when we started talking about putting the video together, the FAIR concept, which is actually, the RAM concept is in 2010, right, when it was published. So it's just about 11 years old now. FAIR is much younger than that. It's more like 4 or 5 years old. And it does give us a way of beginning to grapple with the quality of the information as data. If you use the FAIR criteria, that gives you some sense as to how it gives you a way to approach assessing that information, not from a safety point of view, but from an information quality point of view, which is the first step, in my opinion. As Leah said, first you say, how does this information apply to my situation? You also have to say, how reliable is this information? And then you start making the steps. So go ahead, Neil.
Yeah, thanks, Ralph. Thanks, Leah, for what you're presenting today. It's an overwhelming problem, but let me try to reduce what I see as a huge problem to a couple specific data quality issues. We in the EH&S world, and many in the more broad chemistry and chemical sciences world, have been taught to look at the GHS classifications in order to make some risk or some hazard assessment. Over the past 5-7 years, the reputation of the best source of GHS information in North America, whose example safety data sheets Leah used as an example, reputation for the quality of their data has markedly declined. It forces one to look at GHS information and say, what is the most reliable source? Now, I was 2 years ago involved in a intense project in which I looked at sodium chlorite, ITE, and tried to get the correct GHS classification as an oxidizer. I went to the 2 primary global manufacturers, one in the US and one elsewhere. One classifies it as a GHS class Cat 1 oxidizer, and the other as a Cat 2 solid oxidizer. That's an enormous difference in handling. Now, those 2 issues, the decline of the reputation of at least one source, and the fact that manufacturers don't agree on primary information for others, as a second example, raises the issue of where do we in the EH&S world advise our customers, students, etc., to look for reliable GHS classification, data quality. Thank you.
So that's one of the advantages of the PubChem's LCS Lab Chemical Safety Summaries is they give you a broad number of sources of GHS information. And so you can get some sense, because the Europeans have a large collection of different vendors, you can often see that 85% give it this rating and 15% give it that rating. And then you can go and dig into it to figure out why that difference may be there. Sometimes you can tell there's different process that they're thinking about, or sometimes you can't. But so there is some data about that, and that's why I think the FAIR criteria are so important, that they help you start thinking about, okay, why are we seeing these differences? The data differences may be appearing because the FAIR principles aren't being followed. Sammy, do you want to add something?
Just the aggregation, that's where I point students. So because students don't even have the background to make an informed decision. So I say at least this will give you some aggregated data on how many of the suppliers reported what data and about a chemical. And so at least I point them there as a way to show them they are going to find disparate information and they're going to have to learn to make informed decisions. So, you can't teach them everything, but you can at least teach them that you are going to see inconsistencies and to be careful when you're looking at SDSs.
That's a great point. And Sammy, thank you for pointing that out to your students too. So I'm just showing here on the screen, this is PubChem's pulling this data, for example, on GHS classifications from European Chemicals Agency. And these percentages represent the percentage of companies that reported to the agency the different classifications. When we've dug into this at different times, sometimes this relates to things like, the form of the chemical. So they may still be using the same chemical abstracts number, for example, but it's actually different forms of the chemical. And of course, that might impact, for example, some of the hazards. But other times, to Ralph's point, it's just the way they've reported the data, they may use different units, or they just may not describe whether they've used a testing method that's open or closed, for example. And those things can, as we know, impact the outcomes of those tests. But because they weren't very clear about how that was reported, the data don't really match, and you get these misalignments. So that's the data. I mean, that's very messy, and it's not very high quality at that point. And there is a lot of sorting that needs to be done through that. And this compiling in PubChem was our first way of trying to understand how much disparity there is in reporting. And then the next step would be to investigate how much of that is because of real factors like different form, and how much might be errors.
Leah, this is Sammy again. Can I just point back to Neil that Neil, when I saw Sigma Aldrich SDS say that nitric acid reactivity was not known on an SDS, that was my big eye-opening moment.
Yep. No, Sammy, I hear you. Let me expand what you're all talking about in terms of data aggregation. One of the real advantages of the European Chemical Administration Agency, ECHA's compilation of GHS classifications is about 90-some%, I don't remember the exact 90-ish, of the product of the chemicals listed, ECHA has chosen and puts a check mark next to what they consider the most reliable classification. And that at least provides a organizational evaluation using a nominal set of criteria for uniformity of choosing the best set of classifications. If you're not familiar with ECHA's database, you really should take a look at it.
Agreed. Yeah, they have worked really hard, in particular, that agency of the different ones that we've worked with, as far as data that gets pulled into PubChem.
Yeah, I make no bones about it now, Leah. I've given up on all other sources of GHS classification. And then I'm tied up right now in a year-long project of developing a global SDS platform for a chemical company. And it turns out that the Purple Book is not uniform across the globe. Even the way that GHS classifications are assigned in different countries is not the same. At least the countries, the three of us in North America all use the same standards for GHS classification. But I can't say that for a lot of the rest of the world.
Yep, agreed. And you can see that here. Actually, this is the European consolidated classifications. This is the reporting from Australia, and this is from Japan, for example.
Yeah.
Haven't dug into, this is your sodium chloride, Neil. I haven't dug into what happened to your oxidizer here.
Yeah. No, I don't want to go there because it'll trip me over some proprietary stuff. But I've been working on a lot of polyphosphates lately for water treatment, and it's amazing. Malaysia and Indonesia have totally different rules for how to take factual information about, let's say, toxicity or even corrosivity and assign GHS classification. you know,
So
and
now-
they're next door neighbors.
So now you're talking about a situation where the original data may have been, measured in a very high quality, careful way and even reported very clearly, but how it's used, it varies. Yeah.
Yeah, and the purple book is supposed to have solved that, but the last year of dealing with 90 different countries, we're generating SDSs for 90 different countries in, I forget how many languages. And the classifications don't agree. And I just made a arbitrary decision. I refuse to live with that. So we're taking the US classification and applying it globally.
So my one comment there, though, I would also just encourage people, you may very well have to make such decisions. Please cite which one you use, though, so we do know where you got it from. So we can track back to the data. Then that's part of good data practice, is even once you have made a decision about how you're going to use your data, to let people know the sources you've used. I'm sure everyone on this call knows
point. That's a very fair point. And in fact, I hadn't thought about it that way, but in the context of your phrase fair, one should look at on an SDS, what agency have jurisdiction SDS has been written for. So has it been written for US OSHA or some other? And that should be reported on the SDS. Good point, Leah. I had never thought about it that way.
Yeah, I think that I would like to see more sources on the SDS. That's definitely been one of my long list of wishes.
This is Sammy again. That I just said that yesterday to a group of graduate students, but that was one thing going through the literature, trying to find safety statements. They're not citing them like they would their research. And I think that we need to point that out to the community, that it's really important to cite your sources on safety information.
So thanks,
well, that's
Sammy.
got to go back. That's got to go back through Grace's team and be fed back into the peer review and editorial process.
Yep, and that's one of the things we recommend in the chapter that's targeted for authors who are writing safety statements, also, is to reference their sources. Yep. I wanted to say a little bit more about FAIR. I just saw it coming up in the chat a bit, and thinking about some of the things that Neil's been talking about recently. For those of us who think about the FAIR, and the FAIR acronym originated in the data science community. So we're thinking a lot about data handling and trying to compile data, such as PubChem's doing here. Is that a lot of what Neil was talking about was that interoperability, different ways of different criteria. Some of the other comments in chat are, how GHS is structured and what its intention is, and those do impact those issues of interoperability. Can you apply this way of organizing the data to your case? And if people have used different systems for organizing, they may not be, those classifications may not be entirely interoperable. And there have been others who commented how things are classified according to other types of hazard types, like the NFPA diamond and others. So that's what's meant by interoperability there.
Oh yeah,
go ahead.
I had a
Sorry.
question. When we look at data provenance and all of that, and of course that's what the safety summaries do really well. Have you looked at? I doubt you have, but do you know of any buzz of anybody looking at? It seems like there's an incredible opportunity for blockchain on this sort of data, to be able to get all of this data connected with all of the provenance permanently attached to it forever if we went blockchain on it. You have any comments?
So are people familiar with blockchain? Rob, do you want to give it a
Sure. So
Microsecond.
blockchain is the basis for Bitcoin, that there's a digital ledger, which is cryptographically encoded that anybody can add to, and you will always know every transaction that ever occurred in it. You can't go back and edit it after the fact, which would be the one thing I think would work against using it for safety, would be the liability concerns about not being able to delete data from it. But it's the basis of all these cryptocurrencies.
So I can see, and I've heard discussions circulating about this, and maybe not so much in safety conversations myself, although others may have at other tables, but other places, other circles that I've been in around chemical data. Maybe you can imagine in an authoritative context where there's a formality around the data, and places like ECHA are standing behind that data. And that's a regulatory agency, with a lot of very, formal criteria. Absolutely, I could imagine potentially that kind of data flowing through a blockchain, so that you could, that the ECHA could trace what they've done with it, and the rest of us can see how that data has come into their, into the final analysis, essentially, I guess. Yeah, I mean, I think there just hasn't been enough exploration about how you would take a blockchains that have been developed, say, in different contexts or sectors, and start intersecting them. And that might be a question too, right? I mean, how you think about data and what you use it for, in the research, academic research environment, for example, might be a bit different than how you're thinking about it in the regulatory environment. But provenance is definitely part of this concern here. And I could see that I could see blockchain being a potential way to really help us track this data. Some of this data that we're looking at in PubChem has been, borrowed. It's gone from source to source to source. Cameo's reporting it from ILO, and ILO's reporting it from NIOSH, and it sort of goes around and around, and there might be some transposing errors that happen, and that's a kind of scenario where a blockchain trail could also be helpful, because these are organizations, especially like ILO and others. Those are very high level organizations, and you want to be able to trust that data. Is that kind of getting at what you were thinking of, Rob?
Yeah, basically, yeah. Nobody will have to replow the same ground ever again. And that's right now, I think, is the biggest problem that faces the chemical safety community, is a lot of people end up plowing the same ground. And it's because we're building towards resources like this now that we're trying to help people not do that all the time.
Right, and even data like this and on this SDS, where did this come from, right? Did they search it somewhere and report it here? They're supposed to be measuring it, but I'm not sure that always happens. But they could have the blockchain be part of the SDS formulation, and then you could track where that data came from, how it got here.
Yeah, that's an excellent point, because the GHS, the HASCOM standard specifically just requires the person writing the sheet to collect the data. They can get that from wherever they want to. And if you were to require them to include a source, God, that would be incredible. There is no requirement for testing. So on your screen there where it says viscosity, explosive, oxidizing, no data available, there is no requirement to perform any testing in that regard. So it's great that if somebody came along later, they could add on to that, boom, that data right there. If that data came up, or if there was conflicting data, it could be appended on there. And you could see the evolution of the SDS. Again, from a liability standpoint, that's actually probably useful, because they can point out that they were consistently updating their SDS, and that it's encrypted and verified that nobody's tampering with it.
Good point, Rob. So you can continue to update from this source, and you can follow that forward. And again, that's a very formal environment, right? This is a regulated environment. So I could definitely see potential for blockchain. I wouldn't be surprised if ECHA has thought about that. They probably have an advisory team looking at it or something. I just haven't been part of that conversation.
Leah, we have about 8 more minutes. Do we want to talk about the Zotero work we're developing?
I did show that really briefly up here. So that was this list of sources on the CHAS page. Ralph's posted that.
So the key point here is that we are transitioning the CHAS web page in coordination with the ACS safety web page, which is going to be high quality, well-developed information. The CHAS web page is more going to be cutting edge research sort of information. And so where Leah's pointing to on the website is where you can find our current list of information sources. But we are interested in expanding our list. So if you switch over to the Zotero site, which you can find the link to on the previous page right there, there's a link to it. This is publicly available, a list of the 20 or so general sources that Leah's put together, and then 26 or so for nano safety. We also have another group there working on the lab safety culture question, particularly around lab safety teams. So we do expect to develop not a kind of like PubChem in the sense that we are not storing files on our website. We are storing links to files, and we will be trying to develop an ongoing evolving list over time that can support people looking for better or for information resources on either technical questions like we've been talking about today, or more safety culture information like the lab safety team people work with. So we do have ambitions to really improve the reference resources available on the CHAS website, in addition to the bulletin board kinds of information about workshops and national meeting abstracts and things like that. Again, we're very open to volunteers and or suggestions for helping to get that work done.
While you've been talking, Ralph, I've just been playing around with a little of the things. So Ralph and I are editors on that library right now. So if you have suggestions, if you'd like to join, if you have suggestions for things to add, reach out to us. I think there's been some in the chat as well. Here's all the ones I've added so far from ACS's Committee on Chemical Safety. There's quite a few guidelines that are generated by that group, for example.
Does anybody else have any questions or comments on this general topic?
Thanks, Neil, for your comment in the chat. You know, I think in addition to sources that people like, and I haven't thought about this, Ralph, maybe you have or others have ideas about this, but it would be really great to figure out a way to collect some of those challenge points. As I mentioned earlier, the committee is working on a white paper about some of those challenges. And if we can compile them and characterize them, that it gives us an easier opportunity to follow up and figure out different ways of approaching some of this work to address some of those challenges. So I think, sort of, for example, we have identified the regulatory community as a major target audience to work with. And and so, for example, Rob's suggestion about blockchain, I'd be interested in, as we engage with them, to talk with them about that. But if, and some of the examples that Neil raised, but please report if we can figure out a way to collect that information to places where you're having trouble with sources, or lack of sources, or incorrect sources, or all of the above.
Yeah, when we approach regulatory agencies, we need data, and we won't have data because it's going to be anecdotes, but anecdotes get people's attention, and the regulators, if you convince them that it's a potential problem, then they can put some resources into turning your anecdotes into data. So I think we'll go ahead and close it out at this point. We will, this was the top topic of interest for when I did the survey in November for CHAS chats for 2021. So we will have another CHAS chat in April, topic to be determined. If people want to provide me with suggestions for topics, we'd be glad to find people to talk about them for you. So thank you everybody for attending today, and glad to see you again. Thank you.